Okay, let us look some of the problems. Okay, now we'll see some of the basic concepts on unit vector and all that. Okay, so which is very important. Okay, let us find the unit vector parallel to the vector which is given as minus 3i plus 4j. Okay, so I've been given vector which is 3i plus 4j. Let us find the unit vector for this. Okay, which is parallel to this vector. So we have a cap, which is represented as a unit vector, which is 1 divided by mod a and a. So this, if I represent this as a, okay. So let us find what is mod a. So mod a will be square root of this is 9 and this is 16. So I'll get root 25, which is 5. So the unit vector parallel to a will be, that is a cap, which is minus 3i plus 4j divided by 5. Okay, where ij are the components of a vector. Okay, let us move on to next problem. Suppose if I have uh, a vector again a, which is 12j plus nj, okay, and mod a, which is 13. Okay, let us find the value of n. Okay, let us find what is n here. So we have been given a vector. Okay, we have also the modulus of the vector, which is the magnitude or the length of the vector, so which has been given as 13. So mod a will be square root of 12 square, and this is n square, which is 13. Okay, so we know 12 square, which is 144. When you simplify it, I get n square as this as 13 square, and I get n square as 25. So n will be plus or minus 5. Okay, let us find next problem. Okay, suppose if I have been given as one of the side of the square, okay, be represented by some vector, okay, some vector, say 3i plus 4j plus 5k. Okay, let us find the area uh, of the square of this vector. Okay, let us find that. Now we know this being vector, let us represent as e. Okay, then mod of this would be square root of this is 9 and 16 and 25. So this results to 5 root 2. So we have, this would be one side of the or the length of a square. So I need the area. So area would be square of this. So this is square. So I get somewhere around 50. So this is the solution. Okay. Please remember how to do it. So what we have done is we have taken a vector, okay, and we need to find, first we need to find the one side of the vector. Once that is done, then let us find what is the area of the square. Area being square of this, the result which you got. Okay. Further, let me find the direction cosines of the vectors. Okay. Now, suppose if I have been given vector of 3i minus 4j plus 5k. Now, let us find the direction cosines of the vector. Okay. Now, let us represent this as r. Okay. So, the mod r would be square root of this is 9, this is 16, and this is 25. When you simplify it, I get 5 root 2. Okay. Now I need direction cosines of this DCs. So that would be the coefficient of I, j, and k. So that would be 3 by 5 root 2. Okay. And minus 4 by 5 root 2 and 5 by 5 root 2. Okay. So these are the direction cosines. Okay. Now further, let me take another example. Now let us show that I have a vector which is I, j, and k. Okay, is equally inclined to some points which is O. If I consider O, X, okay, Y, and some Z. Okay, O, X, Y, and OZ. Okay, this being I, J, K. Okay, let us get that result now. What will be the angle? Okay, so if I consider the angles as alpha, beta, and gamma here with respect to x, y, and z. Okay, axis. So cos alpha will be 1 by the magnitude of this. If I represent this as r, the magnitude of r would be square root of 1 plus 1, which is square root 3. So this would be root 3. Okay. So cos beta will be 1 by root 3 and cos gamma, which is 1 by root 3. Okay. So which is equal. Okay. Which is equally inclined. Okay. Let us try to solve few more problems. Okay. Now, by using properties of vector addition, triangle law property, and parallelogram law property, and those kinds. Okay. Now, let us find the position vector. Okay. Before that, I want to solve some of the points were given like A, B, and C. Okay. Let us try to solve that. Okay. And D. When given points, let us prove that those sides, which is AB is equal to CD, are equal. Okay, so let us note the points of A, which is 0 and 1. Okay, B, which is 1 and 0, and CD are equal. Okay, So AB is equal to, so that is 1 minus 0 with respect to I, 0 minus 1 with respect to j. So this is I minus j. Okay, CD would be 2 minus 1 into I. This is 1 minus 2 into j. So this is I minus j. So we find these two results are same. So hence proved. Now let us further continue to find the position vector. Okay, position vector name itself position of a vector. Okay, if I have a position vector A and B respectively, uh, which is I plus 3j minus 7k, and another vector 5i plus minus 2j and plus 4k. Okay, and you need to find what is AB. I've been given two vectors. Uh, those are I 3j minus 7k and 5i minus 2j and 4k. Okay, now this would be OA, this would be OB. Okay, so AB would be AB, which is OB minus OA. Okay, so when you find this, you get 4i minus 5j, and this would be minus of minus plus. So this is plus 11k. So that is the solution. Okay, and further, let us again continue. Next problem. I've been given vectors again, the position vectors of three vertices. Okay, three vertices being vertices, of course, a triangle. If I consider a triangle, so those are 2i plus 4j minus k. Okay, and 4i plus 5j plus k. Okay, and another vector 3i plus 6j minus 3k. So the three vectors. Okay, and then you have to find whether it is an this vertices of a triangle ABC, uh, is it a right angle triangle or isosceles or equilateral triangle. Let's find that now. Okay, now if I consider OA, OB as this, and OC as this. Okay, so AB will be OB minus OA. So that would be 2y plus j plus 2k. Fine. BC will be OC minus OB. Okay, I get minus I, j, and minus 4k. Okay, if I simplify it. And you have find that AB and BC. So we have to find AC also. Okay, AC would be I plus 2j minus 2k. Fine. So let us find the mod of this and mod of this and mod of this also. That would be square root of uh, 2 square plus 1 square and 2 square. That results to 3. And BC would be square of 1 plus 1, and this is 16. So this would result to 3 root 2. Okay, and AC, and the mod of that would be 1 square plus 2 square and 2 square again, that is 4 plus 1 5. This would be uh, 9. This is 3 again. Okay, so I got these length or magnitude which I have got. Now when you notice that uh, mod A B and mod AC is equal. Okay, let us we know the property of triangle. So let us see that BC square is equal to AB square plus AC square. So BC square being 3 root 2 whole square, and AB is 3 whole square, and AC being 3 whole square. Okay, so the triangle is isosceles. Okay, one of the side is not equal to the other side, and it is a right angled triangle. So we have this as triangle as isosceles, and it is a right angle. Okay, it is a right angle triangle. Okay, let us uh, try to solve next problem. Okay, okay. Suppose if I have a vector as A, which is non-zero vector, and the modulus of A and M is also a non-zero scalar. If I consider A as a vector and M as a scalar, which is also non-zero, so uh, then MA is a unit vector. Okay, so so mod of M A will be 1. So mod M and mod A is equal to 1. So M is 1 by mod A. Or if you remove the modulus, so M is plus or minus 1 by mod A. So that's the solution. Okay. Right. Please try to notice here A being a non-zero vector and M being a non-zero scalar. Okay. Suppose if I have another problem to find a non-zero vector A, uh, the set of real numbers which satisfy mod of 5 minus x into A mod less than mod 2A. Suppose if I have this consisting of all x. Okay, okay, I've been given now. If you look at this problem, this is an inequality. Okay, now if I remove the inequality, I have to get the result whether it satisfies the condition or not. Okay, let us try to solve this now. Now, since I have product of this, I can uh, individually find the modulus of this. So that would be 5 minus x mod of this and mod a less than 2a. Also for 2. Okay, so 2 being scalar or constant. So I can cancel mod a. Okay, I'll be left with only 5x less than 2. Okay, now when you remove mod, so you'll be having in inequality sign which is ranging from -2 and +2. So if I add 3, if I add 5, okay, to remove 5 minus x, okay, so I'll get this result as 3 less than x less than 7, means that x lies between 3 and 7, okay, which does not include 3 and which does not include 7. So this will be the solution for a given vector which is having the inequality. Okay, now let us find the vector of magnitude having suppose 5 by 2. Okay, units, magnitude or the length, which is parallel to a vector which is 3i plus 4j, which is parallel to vector 3i plus 4j. So if I consider this as a, mod a will be square root of 9 plus 16, okay, which is 5. Okay, 3 square plus 4 square, 25, square root of that would be 5. Okay, and the unit vector would be a cap, which is a divided by mod a. Okay, so that would be 1 by 5 times that of 3i plus 4j. Okay, I got a unit vector. Now this vector, you have been given a magnitude which is 5 by 2 units, which is parallel to this vector a. So that would be 5 by 2 times a cap. Okay, so this would be 1 by 2. Okay, because in the denominator you have 5 and that gets cancelled. I get 1 by 2 times that of 3i plus 4j. So that is the required vector along the magnitude or the length which is of 5 by 2. Fine, let me continue. Thank you for listening. Okay.